Hi, welcome back to the statistics class. So today we are going to talk about some problems about the linear regression, give you more examples about that. So let's take a look at our notes. So matching the correlation from part 1 and calculate the correlation to the corresponding scatter plot. So calculated correlation. Okay, so we have a negative 0.7. So negative is a negative correlation, so it has to be decreasing. So now let's take a look. 1, 2, 3, 4. Which one is negative? Number 4, right? It's really obvious it's going down. So this one is going to be our A. And then the second one is 0.45, which is moderately strong, and also a positive correlation. So we have a 2. Number 2 and number 3, they're both positive. But we don't know. So now maybe we can skip that one and look at number 3, which is 0.06, which is really close to 0. That means that one is not really correlated. So which is 1, 2, 3. So 1 is a curve. We know that 2 and 3 is look like a straight line, but 2 seems more stronger than number 3. But we definitely know that 1 is not related, right? It's not linear. So I would say our C matching for number 1. Okay, whenever match, we cross it. So now we have 2 left. One is 0.92, which is a really strong correlated, and then we have a 0.45, positive and moderately correlated. So from number 2 and number 3. So 2 definitely is more correlated because you can see the trend really clear to see the trend or a belt that looks like going up, right? So this is D, so the last one has to be B. Okay, so the next one is number 2. The scatter plot shows the relationship between the number of rebounds in season and free throw percentage for players in National Basketball Association. So what can we say about the player represented in the top left of the scatter plot? So top left is this part, and then bottom right is this part. So top left means, since you can see this is more like a decreasing correlation, right? Decreasing towards this way. So that means we can say, hey, the player is not getting a lot of rebound, but has a higher free throw percentage. That's for top left. So people with less player not getting a lot of rebound, but has a higher free throw percentage. So for the bottom right is the opposite, right? The player who's getting a lot of rebounds, relatively more rebounds, they tend to have a less free throw percentage. So write it down by yourself in here. Okay, number B. Does the direction of the association appear to be more positive or negative? Well, it's going down. We identify that, so it's negative. Explain what the direction association means in the context. So that means, well, the association is negative. That means the more rebound, when rebound goes up, the more rebounds the player has, the lower free throw percentage tends to be. They're the opposite. When the rebound goes up, the free throw percentage goes down. That's negative correlation. So what value is the best guess at the correlation? Circle 1. So remember, correlation is in the value between -1 to 1, right? So whenever outside of the -1 and the 1, we know that it's impossible. So we can cross these two. So now since this is a negative, right, it's going down. So we can cross the positive ones. And now they have a 0, -0.9 and -0.4. So definitely not 0 because you can still see the trend is going down. So it's not correlation. So which one do you think is more accurate? -9.9 or -4? So -0.9 is a really strong correlation. -0.4 is really scattered, relatively scattered. So from this graph, I would say this is more relatively scattered rather than a strong correlation. So I cross this as well. Okay, which of the value lists in part D are impossible? So which one is impossible? Definitely the outside of the range. 20, -2, and 20. -20, -2, and 20. Because we know that our value, it has to be in between -1 to 1. If it's outside that range, is impossible. Okay. Number 3. In each case, do you expect a positive or negative association between two quantitative variables? Okay, number of years of education and the annual salary. So definitely the more education that you get in, you will get a higher salary in most of the case. So it's a positive. The age of a maximum running speed for adults. So age and maximum running speed. Negative, the older you get, the slower you're going to run. So as an adult. But now let's look at C. Age and the maximum running speed for children. So this is positive. So look, this is really interesting. Even though they compare to the same variable, but because the age differences, it gives you the two different correlation. Okay, number 4. Baseball games can last a long time. How is the length of the game measured in minutes influenced by how many total runs are scored in the game? A scatter plot with a regression line is shown here. And this is the time that we have. The time, predicted time, which the hat means predicted. 158 plus 2.35 times the runs. Use the regression line to predict the length of the game, which 5 runs are scored. Okay, so the time that we're trying to find out, we have a 158 plus 2.53 times the run, which is 5 runs. So the predicted time should be 117.65, which is approximately 171 minutes, because they measured in minutes. Be careful about the units. B. In one game, 5 runs were scored and the total time was 189. Find the residual for the point. So look, this is the observed value. The observed value with the 5 runs was scored. So we know that the residual equals to the observed time subtract the predicted one. Okay, so the observed time is 189 minutes, subtract 171, which is what we found out from number A, which is 80 minutes. That's the residual. That's the differences. Okay, for the game described in part B, circle the corresponding point on the scatter plot and also show the residual on the graph. So now we're looking at 5 runs, which is here. So should be this. So they have 2. When it has 5 runs, they have 2 points, right? But the time that they observe is 189, which is the top one. So it should be here, because this point is approximately 170. It's not 189, not the observed one. And also they want you to show the residuals on the graph. Remember, residual is the distance between the graph. It's not a straight line, because straight line is not the distance. When you measure distance, it has to be perpendicular to that line. So it should be in this direction. And this part is the residual. It has to be Okay, let me straight up. It has to be perpendicular to it. Okay, interpret the slope in the context. So the slope is what? So the slope is 2.5 minutes per round. That means what? So on average, it takes 2.3 minutes more for every additional round. Okay, interpret the intercept in the context. So intercept is what? In here, when the runs equals to 0, right? When the run equals to 0, the intercept would be 158. So it's 158 minutes. That means a game would take 158 minutes even without any run, at least 158 minutes. You can interpret it in this way. Okay, next. So CarMax lists the numerous Toyota Corollas for sale within 250 miles radius of Redlands, California. List at the age of the car and the advertising prices. So by experience, we know that the older the car is, the lower price is going to be, right? Because cars value depreciates over the time. So now make a scatter plot for this data. We're going to use GeoGebra for this. Okay, so remember our first column should be our S value, which is the age of the car. This is the explanatory variable, and also we call it independent variable. And then there's the price in dollar. This is our response variable. Also, it's dependent variable. Okay, I'm going to pause the video and put in all of the data in it. Okay, I'm done inputting all of the value. So the next thing to do is you highlight all of the data set that you wanted to generate the plot, and then click on to variable regression analyst. So you will get the scatter plot. Okay, so now we know that this is a regression model, a linear regression model, and then we plug in this to find the statistic. Okay, so now they ask you, are there any outliers analyzed for the future question using a better model? So outlier is like we're trying to find the point that most away have the largest residual, which means the distance from the point to the line is the largest, the longest one. So definitely on the top one, which is when 8 years somehow is sell above like 17,000, that one. So when we look at the chart, it should be 8 years, the last one. 8 years somehow they sold 998. So this one is going to be our outliers. Yes. The last one, this one, oops. This one. When the 8 years, somehow it sells 16K 998. This data set. Okay, describe the association between the age and the price used in Corolla. Well, this is really obvious. A what? A negative correlation. Like even though we don't look at the scatter plot, we know that hey, the value of the car is going to depreciate over the years. And we know that the older the car, the cheaper. Okay, number D say, do you think a linear model is appropriate? So now let's take a look at the linear model. So they have a different model. Let's change to log model. Well, it doesn't really fit in it's not as fit as the linear model. And then let's look at the power model. And then they have a polynomial model. So yes, I would say linear model is fit. Number E is compute the coefficient determination of explaining the meaning of the context. So now let's look at R. So coefficient determination is R squared. So from the statistic on GeoGebra, we know that R is equals to 0.865a, and we square it. We have 17.496%. So we also need to explain the meaning in the context. So we can say, hey, about 75% of the variation in price can be explained by the age of the car. Find the equation of the regression line. Well, we can find it from GeoGebra, which is y hat equals to this one on GeoGebra. Explain the meaning of the slope in the line. The slope is a negative, right? The slope is negative 844. Let's say it's a negative. That means when the car gets a year, the price is going to depreciate. The price of the car is depreciate $844 for additional year. Okay, explaining the meaning of y-intercept of the line. Y-intercept is when x equals to 0. We know that y-intercept is this one, 17,673 or 74. That means when the car is new, right? When x equals to 0, that means you never use it. The year is 0. The new car cost 7,673 or 74. I'm going to round that up. If you want to sell a 7-year-old Corona, what price seems appropriate? So we can use the regression model, which is y hat equals to this times 7, and then add the intercept. So this is equals to 11,763 US dollar. Okay, you see a for sale signed on 10-year Corolla, and stating that a asking price is 8,500. What is the residual? Is that a good deal? So now let's take a look. This is the observed price, right? So now we need to figure out what will be our predicted price. We use the same model. Instead of times 7, we times 10 because it's 10 years old. So this is equals to 9,229. So the predicted price is 9,000, but now they're selling it with 18,500. So yes, this is a good deal because our residual is the observed price subtract the predicted price, which is equals to negative 729 US dollar. So yes, it's a good deal because it's cheaper than the predicted one. Okay, would this regression model be useful in establishing a fair price for a 25-year-old car? No. We talked about that because this is explanation is way too outside, because look, the data set we have is from 1-year-old to 9-year-old car. 25 years is outside of the dataset range, outside of the dataset range. Okay, so that's it for today's example. If you have any other questions, please let me know.